Hi guys, we're going to continue our discussion about trigonometry, and we're going to be talking about coterminal angles and reference angles. And so over here I have a screenshot. I just grabbed this off of the internet. Once again, if you Google reference angles, you can probably find a billion of these. But what we want to talk about are reference angles and coterminal angles. We're going to start with reference angles. This in your book can be found on page 480 in section 9.3. Also, just like the other video I was talking about, I would advise you to use small handwriting and perhaps more than one color. The reference angle is the acute angle formed by the terminal side of the given angle and the x-axis. All right, we're going to talk about that. Another way to say that is the shortest way to get to the x-axis. And finally, it has to always be positive answer. So whatever the question is, your answer will be a positive answer. Let's take a look. If you have an angle like this, and so again, I cut this off the internet. They color coded it. I realize yours are not. Yours probably are in black and white. The standard angle is this theta. In my paper, it's on green. And then the reference angle is the theta prime. And the theta prime on my paper is in red. So we're going to start in quadrant 1. If you have an angle that's an acute angle like this, the reference angle is going to be the closest way to get to the x-axis. Well, the closest way to get to the x-axis is to go straight down here. I'm at the x-axis. However big that angle was, that's how big the reference angle is. So for instance, let's say this is, I don't know, this looks like maybe about 70 degrees. All right, if this is 70 degrees, then the reference angle is also 70 degrees. Moving into quadrant 2, here we have an obtuse angle. Okay, this one maybe is more like, again, I'm just going to make up a number. Let's say it's like 110 degrees on this one. Our reference angle is the shortest way to get back to the x-axis. So my shortest way to the x-axis is this way. Not over here. That would be the long way. The short way is here. So if this is 110 degrees, how big is my reference angle? Well, if this is 110, my reference angle is 70 degrees because this is 180, right? So this is 110, subtract that away from 180, and you'd get 70 degrees. Moving into quadrant 3, we're all the way down here. How big is our reference angle? Our reference angle is the shortest way to the x-axis. So if I go back here, I'll get to the x-axis. How big is that angle? Well, again, I'm going to have to make one up. Let's say this is like 250 degrees here. Okay, so from here all the way around here is about 250. If I wanted to get back to the x-axis, how far would I go? Well, this is 180 degrees. Accidentally, I keep picking 70. That's a total accident. But this, from 180 to 250, is 70 degrees, right? So my reference angle here would be 70 degrees. Okay, this time I'm going to pick one that doesn't add up to 70 somehow. But here we are in the 4th quadrant. We go all the way around. We come over here. Let's say we are at 320 degrees. Okay, if we're there at 320 degrees, our closest x-axis is over here. How far away is that? Well, this is 360 and we got to 320. That is 40 degrees away from the x-axis. So it's always a positive answer. Even though you could talk about this being negative, we're just going to call it positive. And it's the shortest way to get to the axis. All right, once again, on this section, it does not ask us to draw the angle, so we don't have to. You don't have to. I'm going to just so we can visualize it. If this is my 30-degree angle, shortest way to the x-axis is 30 degrees. Okay, 125 degrees, where is that? Well, here's 90, here's 180, so it's somewhere between there, right? If that is 125 degrees, how far away from the nearest x-axis is it? Well, what's 180 minus 125? All right, that's going to be a 55-degree reference angle because that's the shortest way to get to the x-axis. We're always going to the x-axis. Negative 225. Where is negative 225? Well, negative, of course, means that we go this way. So we're going this way. We want to go past the 180, but not quite to the 270. So we're actually going to keep on going maybe about here. And so then our reference angle is the shortest way to get to the x-axis, and that is how many degrees there? Well, this was 225, this is 180. It's actually negative 225 and negative 180, but we can still subtract those numbers. And when I subtract them, I do get a negative answer. I get a negative 45. But again, we're just going to talk about positives. We're just going to call it a positive 45-degree angle. So my reference angle there is 45 degrees. All right, how about 430? That is more than 360. How much more? I'm going to go, this time it's positive, I'm going to go in the positive direction, 360 plus 70 more. So I'm going to go 360 plus 70 more. Now I'm up here. And how far is it to the nearest x-axis? Well, I just did my subtraction a second ago. That's going to be a 70-degree reference angle. So the reference angle is how far away from the x-axis is it? And that is a concept that we're going to use a lot. We're going to be going back to talking about, I don't know, different things like sine, cosine, tangent, for instance, and which angle are we looking at? We're always going to go back to the x-axis to figure that out. Okay, those were all in degrees, so that you now understand what a reference angle is. What if we talked about it in terms of radians instead? Well, once again, it does not ask for a diagram. You don't have to draw a diagram. I'm going to, because it's going to make some sense to us. 4 pi over 3 is like 1 1/3. So I know this is 1 pi. I know that this is 1 1/2 pi. Is 1 1/3 more or less than 1 1/2? It's less than. So this angle is going to be all the way over here. How far away from the x-axis is that? Well, it's pi over 3 radians away from the x-axis. And so we're thinking in terms of pi and radians and fractions, whereas up here we were thinking in terms of 360 and degrees. But it's the same concept. Okay, 7 pi over 6, you might be able to do this without visualizing even. Because this is 7 pi over 6, that's 1 1/6, right? So if I go 1 1/6, then I'm just going to go like right here. That's going to be 1/6 of a pi away. So the reference angle is pi over 6. All right, what if we go in the negative direction? Well, this is 1/2 a pi in the negative direction. This is a whole pi in the negative direction. So it's going to be over here somewhere. Negative 2 pi over 3. How far away from pi is that? It's 1/3 of a pi away. So my reference angle is pi over 3. All right, last one. And again, if you can even just think in terms of fractions, not even visualizing, but just in terms of fractions, because we know that pi is over here, so how far away is 3/4 of a pi going to be? Our reference angle is pi over 4, because that would add up to get us to pi. Sometimes people want to say, what is a shortcut like? Do I always want to add up to pi? Do I always want to add up to what? You could always add up to pi or 2 pi, depending on where you are. Like each of these actually, oddly, these all came into the 3rd quadrant. This one was in the 2nd quadrant. But if there was one in the 4th quadrant, you would want to go over to the 2 pi. Okay, so either adding up to pi or 2 pi. You're basically asking yourself, what do I need to add here? Or maybe it's subtract, depending on where it is, to get to the pi or to get to the 2 pi. All right, coterminal angles. Coterminal angles, the actual definition, 2 angles with the same initial and terminal sides. To find them, you add or subtract 360 degrees. It's basically one way to think of it as a difference in perspective. How do you see it? So let me show you. All right, let's say you have this angle set up here. And notice I didn't put any arcs on there, and that was on purpose. Because maybe one person says, hey, this is a 200-degree angle. And someone else says, no, I didn't see it that way. The way I see it is a negative 160, right? Either person could be right. Was it a positive 200 or was it a negative 160? I don't know, because we didn't have those little arcs drawn in there. It could have been either way. And someone else says, no, I like to take the long way about it. I'm going to look at it the long way. I'm going to go around and around until I get here. And that person says it's neither one of these. It's actually 560 degrees. Which person's right? They're all right. Because we are just looking at the angle itself, not how many turns it takes, and not which direction you go. Just those rays only. To get that, we added or subtracted 360 degrees. If we took 200 minus 360, we would get negative 160. If we took 200 plus 360, we would get 560. And so the answer, all of these are right. Another thing that I didn't write in here that you might write in here is that there are an infinite number of possibilities. So there are an infinite number of possibilities because I could add 360, I could add another 360, I could take another 360, I could add as many as I wanted to. The same thing with subtraction. I could subtract 360, I could subtract another 360, I could subtract another 360. So we are just adding and subtracting multiples of 360 degrees. Okay, let's try another one. Let's say this person says this is a negative 150 degree angle. The other person says, what are you talking about? That's not a negative 150 degree angle. That is a positive. How far would we go? 210. Positive 210. And someone else says, no, it's not even a positive 210. It is a positive, and they go all the way around, and they say it is a positive 570. None of these people are wrong. They are all right. However, this question says, give one positive and one negative coterminal angle. So I've just come up with two positives, which is fine because there's an infinite number of possibilities, right? But I actually want to give one of my answers to be a negative. So I am going to subtract 360 from this, and that's going to give me a negative 510. So once again, all of these people are all correct. This angle could be talked about in any one of these modes. Any of those is fine. I think you're getting the point. Will you try number 3 and number 4 and see what you get? All you have to do is add 360 and subtract 360. All right, for 270, if I add 360, I get 630. If I subtract 360, I get negative 90. And if you think about it, here's the point I'm talking about is that's a 270 or a negative 90. Makes sense. For 540, if I subtract 360, I get 180. If I add 360, I get 900. But I need one negative, and I don't have a negative yet. So I'm going to take this 180, and I'm going to subtract another 360. And when I subtract another 360, now I'm down to my negatives. And so here is one negative answer and one positive answer. All right, well, anything we do in terms of degrees, we also have to understand it in terms of radians. When we're talking about radians, remember we were doing 360s, right? We were adding 360 or subtracting 360. Now we're going to add or subtract 2 pi. I'm going to go back to drawing just for a couple of them, just so we can kind of see what's going on. Pi over 4 is right here. And so this person says it's pi over 4. This person says, nope, I want to go the backwards way, and I'm going to go all the way over here. Where is that? Well, that's 1 pi, 1 1/2, 1 3/4. Well, 1 3/4, that is 7 pi over 4. But of course, that's in the negative direction, so it's a negative 7 pi over 4. And then, of course, you have your friend who always likes to take the really long way. So they're going to go here, and then they're going to keep going, and then they're going to come all the way around here, and they come up with 2 1/4. Well, 2 1/4 makes 9 pi over 4. So again, it's kind of, can you do mental math with fractions? You don't have to do it mentally. You can use your calculator. But if I took pi over 4 plus 2 pi, and what did that come out to be? Pi over 4 minus 2 pi, and what did that come out to be? And those are my two answers. So that's what we're going to do in this section, is we're going to add 2 pi and subtract 2 pi. Let's do another one together, and I'll have you finish the last two. All right, so if we add 2 pi to this, we would get 1 2/3, which is 5 pi over 3. If we subtract 2 pi from it, we would get 2 1/3, which is negative 7 pi over 3. I forgot to draw these, so let's just go ahead and take a second to draw this in. It's going to be down here. So that's a negative 1/3. This person says, nope, it's a positive 5/3. This person says, nope, I'm going to go the really long negative way and go all the way around. That is negative 1 1/3, or excuse me, negative 2 1/3. So again, take a minute to try these and see what you come up with. Okay, for this example, one way to think of it is in terms of fractions. 2 pi, well, we could call 12 pi over 6. So if we add and subtract 12 pi over 6, we're going to get 7 pi over 6 radians and negative 17 pi over 6 radians. Okay, on this one it was in terms of fourths, so that's 8 pi over 4, adding and subtracting. If we add 8 pi over 4, we get 23 pi over 4. If we subtract 8 pi over 4, we get 7 pi over 4. And then the answer says we have to have one positive and one negative, so I'm going to subtract another 8 pi over 4, and I get negative 1 pi over 4. And again, if we look at where this is, 15 pi over 4 is just short of 2 pi. So it is 1 all the way up here. If we think about where this is, it is just short of 4 pi. Well, where's 4 pi? Well, here's 1 pi, here's 2 pi, here's 3 pi, here's 4 pi. So this has gone 1, 2, 3, almost 4 pi. So this is the original one. Someone else said, well, that's silly. Why did you go that whole way? Why didn't you just go this way? It was a negative 1/4 of a pi. And someone else said, well, I like going positive, so I'm going to go this way, and I'm going to get 7 pi over 4. All three of those are the same thing, but you do need to have one positive and one negative. All right, that is our lesson on coterminal and reference angles.